What's up? Today we're going to keep on talking about this trig stuff. We're going to do it for a few more lessons here. But let's remind ourselves what I've asked us to look at so far. Here's the unit circle. Right? And if you remember, the values I've asked you to know off the top of your head are the ones that are right here on the main axis. So 0, pi over 2, pi, and 3 pi over 2. Right? As well as these values that are here in the first quadrant. Okay? So it gives us, 7 of those values that you're being asked to know. Okay? So, for instance, if I just said to you, what is cosine of 60 degrees? Okay? I'd like you to know off the top of your head that if you remember, cosine is the first part of this ordered pair. Right? That gives you 1/2. Right? Or if I said to you, what is sine of pi over 4? Right? Sine is the second part of this ordered pair, so that's just square root of 2 over 2. Right? Or if I said cosine of 3 pi over 2, I'd like you to know off the top of your head that, we're right down there, so it's going to be 0, and so on. All right. Now, the reason I want you to know those values is if we have just these 3 values right here in this first quadrant known, we can use those to generate these values, and even some other ones as well. Okay. So what we're going to do today, at least one of the 2 things we're going to be doing today, is we're going to be using these values in quadrant 1 to help us get the values in quadrant 2, quadrant 3, and quadrant 4, right, using reference angles. Okay? So let's do a couple of examples of reference angles just to remind ourselves how we're supposed to find these. Right? So if I have an angle in standard position, right, so here's my axis, I start my angle on the x-axis there, right, and then let's say I rotate around here to 120 degrees. Okay. The reference angle is the amount of angle we need to go from the terminal side down to the closest x-axis, right? So there's my reference angle. Right? And if you remember, if the distance from here to here is supposed to cover 180 degrees, then in order for this reference angle to add up right, it better be 60 degrees. Right? So the reference angle here is 60 degrees. Okay? So if I gave you this particular reference angle, right? Let's say we're going to roll around to here, right? Let's say that's 210 degrees. Okay? My reference angle, again, is the angle from the terminal side to the closest x-axis. So there is my reference angle. Okay? Now in this case, from here to here is 180 degrees, right? Which means this last little bit right here is 30 degrees. So my reference angle is 30 degrees. Okay. We can also do this for radian measure as well. Right? If my angle starts here, right, and sweeps around to there, right? So let's say this is the radian measure of 3 pi over 4. Then again, the reference angle goes from here to there. Right? So there's theta r. Right? In this case, the whole thing has to add up to a 1 pi, which means that has to be pi over 4. Right? So this reference angle is pi over 4. Right? And then if we just do one more of these just to remind ourselves, right? Let's say it sweeps out all the way to here. Right? So let's say that's 11 pi over 6 is that angle. Right? And the reference angle then goes from the terminal side to here. Right? So there's my reference angle. Right? If you remember, the distance all the way around the circle is 2 pi, right? Which is the same thing as 12 pi over 6 if you multiply it by 6 over 6. Right? And we've gone 11 pi over 6, so if we subtract that off, I'm just left with pi over 6 here. Right? So that's my reference angle. Okay. All right. Well, that's 1/2 of how we're going to use reference angles to get it. The other half is this. We need to recognize when we are in a quadrant, when is sign going to be positive, negative, or when is cosine going to be positive or negative? All right, so here's my unit circle. Right? And we already mentioned this, but it's worth saying again. Each of these ordered pairs that we've got here, the first half we could read off as cosine, the second half we can read off as sine. Right? And then here in quadrant 1, if you have any point over here in quadrant 1, the first half is positive, the second half is positive. Right? In quadrant 2 over here, the first half of that ordered pair is a negative number, the second half is a positive number. Down here in quadrant 3, the first number is negative, the second number is negative. Oops. And here in quadrant 4, the first number is positive and the second number is negative. Right? And of course, the way we can read these off is the first half of it is cosine, the second half is sine, right? Which means in quadrant 1, cosine's a positive value and sine's a positive value. Right? In quadrant 2, again, if we think about them as cosine followed by sine, that says that cosine's negative in quadrant 2 and sine is positive. Right? Here in quadrant 3, right, you can see that cosine is supposed to be negative, sine is supposed to be negative, and down here in quadrant 4, cosine's positive and sine is negative. Right? So what we're going to do to evaluate these values that are outside of quadrant 1 is we're going to use a combination of reference angles with the right plus or minus sign depending on which quadrant that we're in. Right? So let's look at a bunch of examples. All right, so let's think about cosine of 150 degrees. Okay? It looks like this. Okay? So here is this angle, there is 90, 150, right there. So there's 150 degrees. Okay? And let's remind ourselves what the unit circle is. All right, and you can actually just read this off from the unit circle if you notice, all right? Because we know what the answer is going to be here. Here's 150 degrees. There's the cosine value. So my answer better be negative square root of 3 over 2. Okay? So here's how we can use reference angles to get that particular answer. All right, so let's see. Here is my reference angle right there. And if you figure that out, your reference angle should be 30 degrees. Right? So what we're saying here is that this cosine of 150 degrees, that's the same thing as cosine of 30 degrees with the right plus or minus sign out in front of it. Right? And if you remember in quadrant 2, cosine is negative. Right? Just look at all those values up here. Every single one of these gives me a negative value for cosine. Right? So the right sign here is a negative sign. So it'll be a negative cosine of 30 degrees. Right? And if you remember in the first quadrant, cosine of 30 degrees is the square root of 3 over 2. We put our appropriate plus or minus sign on it, and look, we get the answer we were looking for, that negative square root of 3 over 2 number right there. Okay, let's do a couple of others here. What if I wanted, let's say, cosine of 5 pi over 4? Right. Again, just reading that off the chart, it should be negative square root of 2 over 2. So again, let's see if we can get that answer. Okay. So here's my reference angle. It's right here. 5 pi over 4 goes around to there. Right. So my reference angle, again, goes from the terminal side to the closest x-axis, so it's right there. All right. So my reference angle here is pi over 4. Okay. All right, so using reference angles, I'm going to say that cosine of 5 pi over 4 is the same thing as cosine of its reference angle with the right plus or minus sign out in front of it. Okay. In quadrant 3 right here, remember cosine is a negative value. So this will be a negative cosine of pi over 4. And then pi over 4 all by itself is the square root of 2 over 2. So my final answer here is negative square root of 2 over 2, which if you happen to look it up on the unit circle, certainly gives us the right thing. Okay. We can do the same thing for sine as well. Let's say I want to calculate sine of 315 degrees. Okay? So again, using reference angles, let's see what we're supposed to have here. 315 degrees starts, let's see, there's 0 degrees. We go 90, 180, 270, so right about there maybe. That's 315 degrees. So the reference angle from here to there is, let's see, it's supposed to be 360, so that's 45 degrees. So I'm saying that sine of 315 degrees is the same thing as sine of my reference angle, again with the right plus or minus sign put on there. In quadrant 3 down here, right, you can see that sine's supposed to be negative. So this is going to be the same thing as a negative sine of 45 degrees. Sine of 45 degrees is square root of 2 over 2, and then don't forget to carry your negative sign along. So there's my answer. And again, if you go to the unit circle just to verify it, yeah, it certainly works. Okay. All right, so again, what's nice about using this reference angle thing is, for starters, it's not that hard to do once you get used to it, right? And all that means is I just need to know these values to get all of these others here, here, and here, right? So it can make life a good bit easier in terms of learning that unit circle, all right? Let's see how else we can use this idea of reference angles and using the right quadrants too. Look at this kind of a problem. If I said to you that cosine of x is equal to 1/7, okay, and I said that angle x is in the 4th quadrant, right, how can we find sine of x? Okay. Well, a couple of hints here. First of all, if x is in the 4th quadrant, remember your sine function is a negative value there in that 4th quadrant, so we have to kind of keep that in our head. And for the cosine of x equals 1/7, we can use triangles to help me figure out the rest of it. Right? So if this is my right triangle, there's my angle x. Right? Remember, cosine of x, cosine is the adjacent over the hypotenuse. Right? So I can make the adjacent side 1 and the hypotenuse 7, and well, we're going to need to figure out what this side is. Right? But I can use the Pythagorean theorem for that. That says that y squared plus 1 squared is going to be that hypotenuse squared. Right? So y squared plus 1 is 49. And then if I subtract 1 from both sides, I get y squared is 48. And if you take the square root, you get y as the square root of 48. Okay? And we don't need to worry about the plus or minus here because we don't want a negative sign for that distance. Right? So this length is square root of 48. Right? So the question asked us to find sine of x. So sine of x, again, if you remember your SOHCAHTOA stuff, that is the opposite over the hypotenuse. Right? So sine of x here is square root of 48. That's my opposite side. The hypotenuse is 7. And then don't forget, x is in the 4th quadrant, which means my sine value has to be negative. So to finish this off, sine of x is going to be a negative square root of 48 all over 7. Okay? So we've kind of combined the idea of using the proper quadrant with these triangles we've been messing around with a little bit. Okay? All right, let's do one more of these just to practice it. Let's say that sine of x equals 3 over 8. Let's say x is in the 2nd quadrant. Right. I want to find, well, what's that? Right. I want to find cotangent of x. Okay, so what's that going to equal? Okay. Well, if you remember, tangent of x is sine of x over cosine of x. Right? Or if you think about your SOHCAHTOA stuff, it was just the opposite over the adjacent. Right? Cotangent of x, and we'll talk a lot about this in a few more minutes too, is just tangent flipped over. So it's the adjacent side over the opposite side. Right? And in the 2nd quadrant, don't forget that sine of x is positive and cosine of x is negative. And if you have a positive over a negative number, that gives you a negative result overall. Right? So we're going to have to remember to put our negative sign on the end of our answer here. Right? So let's build our triangle. Right? So there's my right angle, there's my angle x, and sine of x is 3 over 8. That means the opposite side over the hypotenuse gives me my 3 and my 8 right there. So let's figure out what that value is for y. Okay? So we can use the Pythagorean theorem. 3 squared plus y squared is 8 squared. So 9 plus y squared gives me a 64. Subtract 9 from both sides gives me a 55. And then we'll take the square root to get y being the square root of 55. Okay. All right, so that's my triangle. So let's go back to our value for cotangent. Okay. It's going to be the adjacent side, which is square root of 55, over the opposite side, which is 3. And don't forget to carry down that appropriate plus or minus sign here, which again gives me a minus number. Okay. So there's my value for cotangent of x. Okay. All right, so that's kind of nice, right? We can use these reference angles, these quadrants, to help us figure out a bunch of different trig values, right? But wait, there's more, right? So far we've looked at sine of x, cosine of x, and tangent of x. Right? We just talked about cotangent of x, which is just tangent flipped over. We've got the same thing for sine and cosine. If you take sine and flip it over, that's called cosecant of x. If you take cosine and flip it over, that's called secant of x. Right? So if sine of x is the opposite over the hypotenuse, then cosecant of x is the hypotenuse over the opposite side. Right? Over here, if you remember, cosine of x is the adjacent over the hypotenuse. So secant of x is the hypotenuse over the adjacent. Right? And tangent of x, we've already talked about being the opposite over the adjacent. And cotangent of x, if you flip that over, gives me the adjacent side over the opposite side. Right? Now, if you flip something over, that's called the reciprocal. Right? So these three are called the reciprocal functions, right? At least the reciprocal trig functions. Right? And we can find values for these using our first quadrant values and the right plus or minus sign as well. Right? So let's say I wanted to find, how about tangent of 30 degrees? Okay. Well, remember, tangent is same thing as sine over cosine. So that's sine of 30 degrees over cosine of 30 degrees. Right? And let's remind ourselves about that unit circle again. All right, and again, if you look at 30 degrees, right, sine of 30 degrees is 1 over 2. Cosine of 30 degrees is square root of 3 over 2. Right? Now, if you remember, a fraction is just a division problem. So that's the same thing as 1/2 divided by square root of 3 over 2. And if you divide by a fraction, remember you flip it and multiply. Right? And then I can cancel off these common multiples like that. Right? And I'm left with 1 over the square root of 3. Right? And depending on the book you've got, this can sometimes be a pretty embarrassing thing for mathematicians, having a radical in your denominator. So I'll multiply the top and bottom by a square root of 3. And if you multiply across the top, you get square root of 3, and across the bottom, you get 3. So that's the proper form of the answer. So that's what tangent of 30 degrees is. Right? So again, if you know these values from that first quadrant off the top of your head, you can make the tangent ones, and we'll do some for secant and cosecant here in a minute too. Right? What about this example? What if I wanted tangent of 210 degrees? Okay. Well, again, here's that unit circle. And if we think about it, this is going to be the same thing as sine of 210 degrees over cosine of 210 degrees. Okay. Now again, you can have the whole unit circle memorized, right? And we can pull off the answers right from this part. But let's use our reference angle stuff to help us out. Right? So sine of 210 degrees. let's see, 210 degrees looks like this thing, right? There's 90, 180 comes down to about right there. So there's 210 degrees. Right? The reference angle from here to here gives me 30 degrees. Right? So that says that sine of 210 degrees is the same thing as sine of 30 degrees. And in this third quadrant, that's the same thing as putting a negative sign out front there. So this gives me negative 1/2. Okay? For cosine of 210 degrees, okay, its reference angle is also 30 degrees. And in quadrant 3, the right plus or minus sign for cosine is also negative. Okay? So cosine of 30 degrees is square root of 3 over 2. So when you put that negative out front, you get negative square root of 3 over 2. Okay? So tangent of 210 degrees is that sine value over the cosine value. Okay? And to help out here, you can do the flipping and multiplying we did on the last one, but I'm going to multiply the top and bottom by a negative 2. Right? Because if I do that, it will get rid of the fractions in the denominators, and it'll get rid of those negative signs. Right? So what I'm left with is a 1 up top and the square root of 3 down below, which again we can simplify into the square root of 3 over 3. Okay. All right. What if I wanted something like, how about secant of 120 degrees? All right. Well, again, secant is the same thing as the reciprocal of cosine. Right? So what I'm going to do is let's find cosine of 120 degrees, right? And then just flip it over. Right? So for cosine of 120 degrees, again, here's my reference angle. Right? So that's where I'll start it. It'll end about right there. So there's 120 degrees. So this reference angle right here is 60 degrees. Right? So cosine of 120 degrees is the same thing as cosine of 60 degrees. And in this quadrant over here, quadrant 2, cosine is negative. Right? So it's going to be a negative cosine of 60 degrees. Right? So cosine of 60 degrees, if you remember, is 1/2. Don't forget your negative sign out front. So cosine of 120 degrees is negative 1/2. Okay? Now I wanted to find secant of 120 degrees. So what I'll do is I will take this value right here and flip it over. Right? And that'll give me a negative 2. Okay? All right, so to find this reciprocal function, I just found the one it's associated with and then flipped over that answer. Right? Let's try a different one here. What if I wanted to find cosecant x where, let's say I want to find 150 degrees. Right? So, wow, that looks really bad. So all I want is cosecant of 150 degrees. Right? Let me try to actually write that again. All right, so here is my reference angle. Okay. And I will go to 150 degrees, which is about right there. So the reference angle goes from there to there, and my reference angle is 30 degrees. Okay. All right, so let's find, well, the reciprocal of cosecant is sine. Right? So to find cosecant of 150 degrees, let's go ahead and find sine of 150 degrees and then flip it over. Right? So sine of 150 degrees using reference angles is the same thing as sine of 30 degrees with the right plus or minus sign out in front of it. Right? And in quadrant 2, my sine value is positive. Okay? So this is going to be a positive sine of 30 degrees. Right? So sine of 30 degrees is 1/2, and they don't need a negative sign out in front of it. Right? So that means that cosecant of 150 degrees, well, if sine of 150 degrees is 1 over 2, then if I flip that over for cosecant, you'll get 2 over 1, which is 2. Okay. All right, and there's one more other little bit of fun that we can have here. What if I gave you this? If I said that tangent of x equals 12 over 5. Can we find the other 5 trig functions if we say that x value is between pi over 2, x and pi? Right? And of course, if you think back to your unit circle, that means we're over here in this particular quadrant. Right? So we're in quadrant 2. Well, let's build our triangle. Okay. So there's my angle x. Tangent is the opposite over the adjacent, so the opposite side is 12, the adjacent side is 5, and I can use the Pythagorean theorem to get this side to be 13. Okay. All right, so normally, and this is probably a quick way to do it, to get sine of x, that's just the opposite over the hypotenuse, so that's going to be 12 over 13. But remember, in quadrant 2 over here, my sine value is positive, so that'll be a positive 12 over 13. Okay. If I want cosine of x, right, so again, here's my angle x, it's the adjacent side over the hypotenuse, and if I put the right plus or minus sign here in this quadrant, quadrant 2, cosine's negative. Right. So tangent of x, right, is supposed to be the opposite over the adjacent, so that's going to be 12 over 5. Right? And then once we have these, we can flip over the other ones. For instance, cosecant of x is just sine flipped over. So that's going to be 13 over 12. Cosine of x, when you flip that over, you get secant of x. Right? So that'll be a negative 13 over 5. And cotangent of x, if you flip over tangent of x, will give you 5 over 12. Okay. One other little thing, I actually made a little bit of a boo-boo here. Tangent is supposed to be negative right there. So just put a negative sign in front of all of those. Okay. All right, because in quadrant 2, if you remember, cosine is negative, sine is positive. So if I have a sine over cosine to get tangent, that should be a positive over a negative, which means tangent is negative. Okay. Which means if you flip it over, cotangent is also negative. Okay. All right, so here's what we're going to be doing today in class. All right, we're going to be doing a couple of little worksheets, and in the book as well. All right, go to page 470. We're going to do 6 through 9, 23 through 49, the odds, 51 and 53. And in the next section, sorry, I can't remember off the top of my head what page it is, but the very next section, it'll be 7 through 37, the odds, followed by 39 and 41. Okay. All right, that's it. I will catch up with you all soon. All right, later.